Thank you so much for joining this lesson. You're most welcome to our tonight's lesson, the Color Joint Trial Examination 2025 1 paper. So let's go through this paper so that we may see what was expected. Those who have been very careful with our programs, they know very well that we have already covered the section 1. So take your time, visit our platform, that is a Shifting Grades Online School on YouTube, and get the best. Let's go through this paper. It's a very interesting examination which has been set by a group of examiners. Color is a combination of Kenya High, Alliance High, Dinana School, and Alliance Girls. So the section 1 already done. Now we are embarking on the section 2, the structured questions, whereby you are advised to attempt only 5 of them. But in this section, we shall handle all of them. So be ready, tighten your belts for the 8 questions. As we begin, usually, I bring my programs here, whereby we have the August holiday programs. For the candidates, for the Form 3s and for the Form 2s, you are invited. Physics, chemistry, biology, that is the sciences. Then we have Kiswahili and English, that is the languages. And we have mathematics. We have a very serious lineup of tutors who are going to equip you for the skills that you need for your KCSE. So kindly make an effort to enroll to our program. Reach out through my number, which is attached on the screen or on this poster, 0704 15 3366. You can also invite a friend to the same program. Remember, you can load your airtime for any network from our platform. Again, just go to your M-Pesa menu, Lipa na M-Pesa. Then now for you to purchase your airtime, the pay bill number is 737356. Then the account number is the phone number that you're purchasing the airtime for. After you've entered the account number, which is the phone number that you're purchasing the airtime for, you proceed to enter the amount. And after that, you complete the transaction and the airtime shall reflect instantly. So please welcome to our platforms. Ensure you get the best from the best. Section 2, number 17, which is our first question here. A point Q, 12 negative 6, is mapped onto point R, which is 410, by a reflection in mirror line M. Find part 1, the equation of the line QR. Then after finding the line QR, we are also advised to find the equation of the mirror line itself. So let's begin with line QR. Or can we do a simple sketching? A simple sketching means let me use this space here just to explain what is happening in this question. I'm not going to have the exact diagram. We're not even having the graphical page. I'm just sketching the information to make it simple. So we are having points here, Q, 12, negative 6. So this is 12, negative 6. This is Q. Now this point is being mapped by a transformation, which is a reflection through the mirror line M, but we don't know where it is. But something we are sure is that the image, which is now R, is 410. So 410 could be somewhere here, R, 410. We say this one is 12, negative 6, that way. So we have those two coordinates. So we can connect Q and R. We connect Q and R like that. So we begin with finding the equation, and the first thing would be the gradient. So how do we get the gradient? change in y over change in x. So change in y, 10 minus a negative 6 divided by 4 minus 12. You see, this is 16 out of a negative 8, giving us negative 2. Now with the gradient, we simply need to express it now using one of the provided coordinates together with another coordinate, xy. So now we express our gradient of negative 2. Change in y would be y minus the y coordinate, which is 10, divided by change in x minus 4. X minus 4, like that. So when I cross multiply here, I'll be having y minus 10. This is equivalent to negative 2x. This becomes now positive. Yeah, because it is negative 2 and negative 4 multiplied. So to make sure that we remain with the equation in the form y equals to mx plus c, we remain with y alone. Then this is a negative 2x. Remember, negative 10 should be brought to the right hand side. So 8 plus 10 will give us a positive 18. So now this is the final stage for that particular equation. It is already in the format that we needed it to be. Look at Roman 2. The equation of line M, leaving your answer in the form ax plus by equals to c, where a, b, and c are integers. So line M is now the mirror line. The mirror line that is going or along which the mirror line along which reflection shall occur. So what do we know about this mirror line? It is that it shall be at the mid and perpendicular to QR. So the mirror line will be passing through the mid. When we talk about mirror line M, it should be perpendicular and also equidistant from the 2 points, equidistant from both Q and R. So if it is equidistant, then we can assume that it is cutting a Q R at point T, for example, at point T. So what will be the coordinates of T? You know that when we are reflecting, if we are reflecting Q to get R, we connect Q to the mirror line and we move on the opposite side an equal distance. That is why we are concluding that the mirror line is perpendicular to QR and also equidistant to point Q and R, which means their point of intersection should be the midpoint of QR. So what is the midpoint of QR? So we find coordinate of T first. T, the midpoint, shall be T, which is the midpoint, shall be given by, we need to take the first x plus the second x over 2. So 12 plus 4 divided by 2. Then the y coordinate, negative 6 and 10 divided by 2. So you see, the coordinate of t shall be r16 over 2, 8, then 4 over 2, 2, that way. So we are having now a coordinate where the mirror line passes. What about its own gradient? The gradient of the mirror line now, we can call it gradient 2, M2. What will be the gradient of this mirror line? Look at the first gradient, which is negative 2, and look at the relationship between QR and the mirror line. It is that they are perpendicular to one another. If they are perpendicular to one another, then we would say that the product of the two gradients should give us -1. If it should give us -1, then the second gradient is the reciprocal with the opposite sign. So the reciprocal of -2 is half, but now positive half. So that when we multiply half by -2, we get -1. So we have the gradient, we have a coordinate where the mirror line passes. Now we need to work out the equation of the mirror line. Remember, the format has been dictated at this stage. Therefore, we will say that half equals to change in y. So y minus 2 out of change in x, x minus 8. Now we can cross multiply 1 times x, 1 times -8, then 2 times y, and 2 times -2 that way. So for us now to be in the format above, we need to start with x, then -2y comes to this side, then equals to -4 plus 8. I know we are together there now. -4 plus 8, because the -8 should be taken to the right where the constants are, and that will give us -4 plus 8, which is a 4. So now this equation again is in the format that the examiners demanded. That is now the right format of the equation. Ladies and gentlemen, remember to subscribe to this platform. Remember to share the link with a friend. Invite somebody to our live lessons. Let people follow up. It's also good for you to know that this lesson will still be available after this presentation. So if somebody sees the link later, they will still take part in the lesson. They will get the best. They will just go through what exactly we are going through. So invite people, even when the lesson has gone, they will access it through the same link. Even yourself, you can revise later. Look at part B now of this question. A point P, -2, -3, is on the line M such that from P, okay, P to Q is the same as from P to R. Then a perpendicular is dropped from P to intersect line QR at N. Calculate the length of PN, correct to 2 decimal places. 2 decimal places. So there is a point N along this line. There is a point P, along this line. A point P. Let me actually extend this line. But yeah, there is a certain point P. Then it is such that its coordinate is -2, -3. And now we are told that a perpendicular is drawn from P to intersect QR at N. So the intersection here is N, not T. When a perpendicular is dropped to a given line, it can only be one perpendicular at that particular point. So if we are dropping a perpendicular from P to the line QR, it cannot go elsewhere. It must be through the point N. So actually, the midpoint that we let here, only that we had not read the question, should be N now, according to the examiner. It should be N that way. So now, allow me say that if we drop a perpendicular to QR, see where we are cutting at N. So now, what is being demanded here? What is the demand statement according to this question? We find the length Pn, correct to 2 decimal places. The length Pn, when the coordinates are at P -2, -3, and N 8, 2. So P -2, -3, N 8, 2. Now we are finding the length between the 2 points. So let's get the vector Pn first, so that we may get its length. Pn shall be N minus P. So this gives us what? 8 minus a negative becomes 8 plus 2. 2 minus a negative becomes a 2 plus 3. So if we have the vector Pn, then it is now easy for us to get the length of Pn, which is also called the modulus or the magnitude of Pn. We need 10 squared plus 5 squared. Then we obtain the square root. So this one should be done very quickly. 10 squared plus 5 squared. This is the 125. Remember, we've been instructed to work with 2 decimal places. So this is 11.18 units. I'm sticking to the instructions of 2 decimal places. So that's a very clear working. Looking at part C now, which is the last part in this first question. A point Q prime, which is 2, 5, is the image of Q after a translation T. Find the coordinates of the image of R under the same translation. So initially, what is the coordinate of Q? The coordinate of Q is 12, negative 6. 12, negative 6. Now we are told that Q is transformed to Q prime by a certain translation, and we're supposed to generally know that when we take a translation and we add the object, we usually get the image. So we can work out this translation vector. The translation vector is let to be xy, such that when we add Q, 12, negative 6, we are supposed to get Q prime, which is 2, 5. So on the x plus 12 should give us 2. So what is x? That should be 2 minus 12, which is a negative 10. What about y? When we take y and we add a negative 6, we should get 5. So for us to remain with y, we should take negative 6 to the right. That will be 5 plus 6, giving us 11. Therefore, the translation vector t equals to negative 10, 11. This is what we call a translation vector. The translation vector involved here is negative 10, 11. So it is negative 10, 11, such that when we add it to Q, we get Q prime. And that is very true. Now, if this is so, then it means now we can get the image of R under the same translation. Coordinate of R, the coordinate of R is 410. So how will it map 410? The same translation. How shall it map 410? So we'll say negative 10, 11. When we add, 410 should now be written as a column vector. This is equal to, we get now the column vector of R prime. Negative 10 plus 4 becomes negative 6. Then we have 11 plus 10, giving us 21. This should tell you that the R now as a coordinate is negative 6, 21. Negative 6, 21. That's one. Negative 6, 21. Number 18. Kantai runs a charity home for destitute children. In the year 2022, the cost of maintaining the home was 117,000 Kenya shillings per month. This cost was made up of food cost, staff wages, and health charges in the ratio 4:2:3, respectively. In 2023, the cost of food and staff wages, that is, rose by 10% and 20% respectively, while health cost reduced by 5%. The first question, determine the 2022 monthly cost of food. The 2022 monthly cost of food. So when we go to food, now we get to the ratios here, and we discover that food is mentioned first. Therefore, the first proportion goes to food, which is 4 out of the total proportions that are 4 plus 2 plus 3. That's a 9. Multiplied by the total cost of running these. So when we compute 4 over 9 by 117,000, I'm getting 52,000 Kenya shillings. 52,000 Kenya shillings. So that's the amount that went to food. After that, I think we can work out the amount that went to the other things. This is food. It's good to indicate. Then we proceed to part B. Calculate the cost of maintaining the home monthly in 2023. So in 2023, there are some changes. But we can get the specific cost of every item in 2022 first. So in 2022, we add staff. Now staff wages occupy the 2 proportions over 9 times the total. So how much did the staff take? This is 2 over 9 by 117,000, 26,000. That went to the staff. Then something else was food, staff, and health. There are some health charges, vaccines, So when we talk about health, it shall be now the remaining proportion, which is 3 out of the possible 9. Now this shall give us, when we take 3 over 9 multiplied by 117,000, this is 39. 39,000. 39,000 that way. So this is now how the money was broken down in 2022. But now we are told that there are some changes for the year 2023. So in 2023, the year 2023, we can start with food. What was the food, the budget for food? We are told in 2023, the cost of food and staff wages rose by 10 and 20 respectively. 10 and 20. So when it increases by 10%, food shall take 110% of the original food. So food now started taking 57,200. What about staff wages? Now staff claimed an increase in their remunerations, which was raised by 20%. Staff wages, 20%. So that means it shall be 120% of what originally was here. So for the staff, it was originally 26,000. Now it raised to, we can check the figure. This is 31,200. Then finally, we have the health. Maybe now the kids grew and very few demanded a lot of attention. And the charges here decreased by 5%, which means it became 95% of originally what was for health, 39. And what are we getting here? 95% of 39,000. This is 37,050 Kenya shillings. So this is now, these are the new vote aids in the year 2023. So the monthly now, we shall talk about the total, shall be 57,200 plus 31,200 plus 37,050. So when we add up all this, I'm getting 125, 450 Kenya shillings. 125,450 Kenya shillings. So that is the amount which was spent in the year 2023 monthly. Look at part C. In the year 2024, the cost of maintaining the home was 153,000 Kenya shillings per month. In that year, the cost of staff and health were 20% and 10% more, respectively, than those in 2023. So in this particular year, staff has increased by 20. So what is the cost of maintaining staff now? 120% of what we have in 2023. For staff, it is 31,200. So for staff, now it becomes another increase by 120 to 31,200. This becomes 37,440. 37,440. This one is on staff. Then on health, there is an increase of 10%. So 110% of 37,050. 110% of 37,050. This is 40,755. This one is on health. So now we are told to calculate what? Let me check what we are calculating. The staff wages monthly cost. Actually, we are already done at that part. So that was the first part. Roman 1 is done. Let's check Roman 2. The percentage increase in food. So how much went to food first? How much went to food? We need to take the 153, which is the new cost of running this home, minus 37,440 and 40,755. So the amount that goes to food monthly in 2024 shall be, let me just convert that, 153,000 minus, we have 37,440 plus 40,755. This is a 74,805 Kenya shillings. Now, if this is the amount that goes to food, and we are finding the percentage increase in food, let's get the increase first. The increase shall be, it is now becoming this amount, and food in 2023 was 57,200. So what is this value? that we are calling increase. This is 17,605. 17,605. So with the increase, we can get the percentage increase. For us to get percentage increase, we need the increase itself divided by the original amount, 57,200. Then now we express this as a percentage. So when we divide this by 57,200, then we multiply by 100. Ladies and gentlemen, I'm getting 30.78%. So this was the percentage increase. This was the percentage increase in the folder. Another good question, which is in number 19. This is from bearings. Guys, I'm still appealing to you to make sure that you are subscribed. Subscribe to Shifting Grades Online School so that you may continue getting notifications. All your classmates are supposed to be aware of this program. It's not good for you to benefit alone. It's good, but not very good. It would be better if all your friends, who truly you call friends, are also aware of a platform like this. Let them even know about our programs. Please invite them to the August holiday assignments, to the holiday program here. Don't come alone, kindly. Invite them, enroll through the number attached. The number is 070415 3366. Yeah, I know we have attached the number here as the M-Pesa number. Some of you are saying that they don't have money, right? Yeah, I know you don't have, but according to how you're benefiting from this, you know where you get money from. So please support our programs with whatever amount, and it shall go a long way. Let's read now number 19 and interpret it together. Number 19, we read it together, we interpret together, and we come up with the solution together. I'm trying to get my protractor to ensure that I measure the angles so accurately. Yes. 4 security checkpoints, P, Q, R, and S, are on the boundary of a game park. The boundary of a game park is surrounded by 4 security checkpoints. Q is 65 kilometers on a bearing of 0.37. That is a true bearing. We begin with 0.37, not just 37 from P. Then point S is 85 kilometers on a bearing of 115 degrees from point P. So it is still from point P. We're supposed to be very careful with that instruction. Given that point R is directly to the north of S and on a bearing of 138 from Q at A, using a scale of 1 centimeter to represent 10 kilometers, show the above information in a scale drawing, in a scale diagram. So we should begin with, look at this. We've been told that Q is 65 on a bearing of 0.37. Therefore, from P. Therefore, because of the word from P, then it means P should be the first location to identify. So we draw a compass. And this is our point P. So now at P, we are supposed to measure an angle of 35 degrees. So an angle of 37, sorry. Yeah, it is 37 degrees, so not 35. So we measure 37 and we produce that line. I think there should be some enough spacing. So allow me just bring it a little bit. The space is there, so we can utilize the space well. So allow me bring the point at this position. P. So now we are measuring 37 degrees. Then you produce that line. I must mention that this is what we are calling true bearing, and it must be measured from the north in the clockwise direction. That's the meaning of true bearing. From the north in the clockwise direction. It cannot be from any other point, and it cannot be to any other direction. So now I'm supposed to go to my ruler using a compass, and I use an arc, which is equivalent to 6.5 centimeters, so that I represent the 65 kilometers according to the scale provided. 1 centimeter to represent 10. Therefore, if 1 centimeter represents 10, then 65 kilometers will be represented by 6.5 centimeters. So 6.5 centimeters, and I measure the distance. I bring it there. After measuring the distance, you know that is now our point Q. But now at point Q, you are supposed to raise a very good compass for your diagram to be very accurate. So for you to raise a very good compass there, please ensure that you measure on the other side another angle of 37. So another angle of 37 on the lower side now, so that the compasses are very parallel to one another. So I'm raising a compass at this point, and I'm ensuring that I have a 37 at this point. So I have a compass at Q. You just transfer the acute angle to the lower side. It is my hope that we are together there. What about the next point, which is a S? S is 85 kilometers on a bearing of 115. A bearing of 115 from, again, P. So at P, we measure 115. It should be from the north and in the clockwise direction. So you identify 15. You identify 115. An angle of 115, and you produce the line through that. An angle of 115. So for you to measure an angle of 115, it means you are leaving an acute of 65 at this point, right? Yeah, you're leaving an acute of 65 at that point. Remember, it is the acute angles that shall be transferred to given points. So with that now, the length shall be 8.5 because of the 85. So 8.5 centimeters. So again, to your ruler with a compass, you measure 8.5 and you transfer that length faithfully. You transfer it so accurately to the diagram, and you mark it off 8.5. This was 6.5. Now we are talking about 8.5. 8.5, like that. Remember, this is S that we are coming up with. After that now, we raise our compass here. There is a 65, which was left at P. Now we measure 65 on the upper side. We measure 65 on the upper side. That is what we are going to do. Guys, it might take long to just do a question on bearing, but it is usually worth it. These are guaranteed marks. These are guaranteed marks. that way. That is after measuring 65 on this side. So I'm able to raise a very perfect north at that point. Look at my norths, very sharp. Now, at this point, we are supposed to read further instructions that say, given that R is directly north of S, and on a bearing of 138 from Q. So it means from Q, we measure a bearing of 138. We measure off a bearing of 38, 138, that is. So 130, 138, yeah, 138. So you just draw that line, 138. Then after, this is 138 degrees. After that, we know that from S, it should be northwards. So you just raise the compass northwards that way. So the intersection is the one that shall give us point R. So that is point R, you see? So we have the relative positions of the checkpoints, all of them. Then now, after coming up with such a good diagram, we can now proceed. Answer a few questions after this diagram. From the scale drawing, determine part 1, the distance and bearing of P from R. Mark the instructions very carefully. P from R, very careful, not R from P. The distance might be correct in either cases, but you have to be very careful because of the bearing. P from R. So the first thing would be joining P and R. You join P and R that way. Remember, this is our north. So you measure the distance from P to R. It is found to be 7.8 centimeters. So 7.8 centimeters should be multiplied by the scale to translate to 78 kilometers. Remember, 7.8 should be observed at an accuracy of 0.1. So 7.7 and 7.9 might be considered to be accurate. Then this is now the distance. Then the bearing. For the bearing, you measure the angle. If you want to give it as a true bearing, it should be from north all the way. So you measure the whole of that angle, which is equivalent to 262 degrees. This one is measured to an accuracy of 1 degree. So it can either be 263 or 261. But the accurate one is 262. You can also construct and compare your values with ours from the studio. Okay. Look at this. You know, after 180, we are adding only 82 at this point. So we can also say that the bearing is, from R to P, we are measuring from the south an acute angle of 82 degrees towards the west. This one now will be called the compass bearing. So you can also give it as a compass bearing. Nobody has dictated us to use the true bearing only. So you can consider compass bearing like that. Look at Roman 2. The distance and bearing Q from S. So Q from S, Q from S. Let me check something here. Q from S. Q from S. So I am supposed to connect Q and S. I'm supposed to connect U and S. U and S, then I measure the distance and also the bearing. Q from S means that bearing will be measured from S. So Q from S, I take first the distance. Let me start with the distance. So I'm getting a 10.2. I also confirm 10.2 multiplied by the scale converts to be 102 kilometers. Then the bearing shall be, we measure the angle. You can just measure the small angle, the acute angle here. This acute angle is proving to be equal to 23 degrees. So where am I measuring the 23 from? From the north, 23 degrees towards the west. This is a compass bearing. Compass bearing should either be from south or north, either in the clockwise or in the anti-clockwise. So it is either from north or south towards either south, from south or north towards either east or west. That means that a true bearing shall be, when we take the L angle of 360 minus 23, we'll get 337. 337 degrees. So 337 degrees means now when we consider the whole angle from this point, from this all the way, that is what we call true bearing. All the way, sorry. All the way means we proceed all the way. So that whole angle is what we are calling 337. We have a part C here. A game warden residential area W is located directly south of P and to the west of S. South of P and west of S, locate the position and hence its distance from P. So south of P means while at P, just proceed downwards. While at P, we just move downwards. Then now, when we say west of S, it means from S, we move to the left. From S, we move to the left. So to move west, it should be accurately through 90 degrees from S. So from S, you're supposed to move directly to the west by going through an angle of 90. So you can measure it or construct the 90 from S. It should be 90. So the intersection now is giving us the residential area, which we are calling W. Is it W? Yeah. Then now this residential area, the game warden, we're supposed to determine the distance from P. So from P, you discover that the distance is only 3.6 centimeters after measuring. So it means 3.6 should be multiplied by the scale to give us 36 kilometers. That's 36 kilometers. Very good one. Very good working. Now let's look at number 20. Number 20 is a question from matrices. This is a Form 3 work. Form 3 work, but it can usually appear. It can appear in either papers. That is why it is in paper. This one is in paper 1 now. Find the inverse of the matrix. 5, 12, 3, 5. we find the inverse. So in the process of finding the inverse, the one thing that we should work out first is usually called the determinant of the matrix. So what is the determinant of the provided max? The determinant is given by product of elements in the leading diagonal. Leading diagonal is having 5 times 5 minus product of elements in the other diagonal, 3 by 12. Now this shall be 25 minus 36. And you know, when you subtract these, you shall get negative 11. So you write your negative 11 as the determinant. Then there is something else that we are calling now the inverse. How do we find inverse? Assuming that this was matrix M, how do we find the inverse of M? It shall be, for the elements, there is what we call the leading diagonal, the diagonal with 5, 5. We also call it the principal diagonal or the main diagonal. So we change the positions for the main diagonal. So you can see we have 5 and 5. Therefore, they are the same digits. So even if you change now the elements' positions, you discover they are remaining the same. But this doesn't mean they have not been changed. So the 5 on our top left is now different from the 5 in the bottom right. So we have changed their positions. Even if they are both 5s, they are in one another's position now. So you change their position. I have to instill that because you might think nothing has changed. And when the digits will be different, you leave them the way they will be. So don't make that mistake. Understand that the 5s have switched positions. The 5 here has gone down here, and the 5 down there has gone up to the other side. So we have changed positions. Then for the other two elements, we change the sign behind them. So for 12, it becomes negative 12. For 3, it becomes negative 3. Then all the elements after that change, main diagonal, we change positions. The other diagonal, we change the sign. After that, now we divide each element by the determinant. So we divide by the determinant. That means we can simply multiply by 1 over 11. This can be left at that point, but it can also be concluded to negative 5 over 11. Then this becomes 12 over 11. It becomes positive there. This one will be 11, negative 1 over 11 by negative 3, so positive 3. And the other one shall be having the negative that way. So now we have the inverse of the matrix. You can simplify to have decimals, but remember when you make them decimals, you will have to round off, and hence you will tamper with the accuracy. So fractions, they are better left as fractions. They are better left as fractions. Now, ladies and gentlemen, we can proceed to read the instructions in part C. We can proceed to read the instructions in part C. Akinyi bought 50 oranges at K shillings and 120 mangoes at Y Kenya shillings from supermarket A for 4,000 Kenya shillings. The following day, she bought 84 oranges and 140 mangoes from supermarket B, spending a total of 816 more Kenya shillings. If the price of an orange was 4 shillings more and a mango was 5 shillings less from supermarket B, part 1, form 2 simplified equations to represent the above information. 2 simplified. Mark that. 2 simplified. Okay, from the first statement, we can talk about 50 oranges for x, or each at x, plus 120 mangoes, each at y, costing 4,000. This is equation 1. Equation 1 can be simplified. When we divide by 10 through, we shall have 5x plus 12y equals to, dividing by 10, this is 400. So this is still equation 1, but now at a simplified stage. Can we talk about equation 2 now? Whereby for equation 2, we need to interpret this information slowly. 84 oranges. Each orange is costing what? Not X now, but it's costing 4 shillings more. So we'll talk about X plus 4 each. Then plus 140 mangoes. And how much are they costing? 5 less. So y minus 5. This one will give us 816 more. That means instead of 4,000, she's now spending 4816. This is now equation 2, but we can have it simplified. So let's simplify equation 2 by doing what? 84x, opening brackets, plus 336 plus 140y minus 700 equals to 4816. The grouping of terms will make us to remain with 84x plus 140y. This is equal to, we take 4816, we subtract 336, and we add 700. This is 5180. 5180. This is equation 2, but equation 2 can further be simplified. When we divide 84 by 28, I'll get 3x plus 140 divided by 28 also, 5y equals to, we so divide by 28 and we get 185. So now the equation is more simplified at that stage. So I have my 2 equations, and these are the equations that we are going to solve now in the second question here. Use matrix method to find the price of an orange and a mango from supermarket A. In other words, from supermarket A, we're finding the values of X and Y. So let's solve this. We are talking of the first equation, 5x plus 12y equals to 500 to 400. That is equation 1. 3x plus 5y equals to 185. These are the 2 linear equations. We can now convert these linear equations to what we call matrix equations. So for us to have a matrix equation, let me not divide the space first. We can first have these. We change them linear equations to matrix equations. We first extract the coefficients 5, 12, 3, 5. This is called the coefficients matrix. Then x and y, we call it the variables matrix. Then we have 400 and 185. We call it the constants matrix. So we have 3 matrices extracted from the linear equations: coefficients matrix, variables matrix, the constants matrix. And how do we now proceed to solve this one? We pre-multiply both sides of the equation with the inverse of the coefficients matrix. And now, coincidentally, we can see that the inverse, the coefficients matrix that we are extracting is the same as the matrix we were interacting with in part A. Therefore, the inverse has already been calculated. So we pre-multiply with the inverse on both sides. So this shall be 5 or negative 5 over 11, 12 over 11, 3 over 11, negative 5 over 11. That is the inverse. We multiply the right-hand side. 5, 12, 3, 5. Xy equals to, we begin with it here, negative 5 over 11, 12 over 11, 3 over 11, negative 5 out of 11 like that. Then here we shall have 400, 185, like that. So we have multiplied both sides of the matrix equation with the inverse of the coefficients matrix. Something else that we're supposed to note with a lot of concern. Now we are noting a lot of tips here as we learn. We are learning, guys. We are learning. And I told you guys, you are given the best from the best. When we take a matrix and we multiply by its own inverse, it is the same as multiplying the inverse. Any can start with the matrix, and this gives us the identity matrix. So we don't need to perform the multiplication on the left-hand side. It is automatic that a matrix times its own inverse gives us the identity matrix. And what is the identity matrix? The identity matrix is a matrix with 1 in the main diagonal and zeros elsewhere, whose value is 1. Therefore, we are talking of the matrix here times its own inverse. They are giving us identity matrix 1, 0, 0, 1. Then xy is here equals to, I think we can perform now the multiplication on the right, whereby we should perform it this way, row times column. So this row times the column here, negative 5 over 11 times 400 plus 12 over 11 times 185. You just carry out that multiplication and you use your calculator wisely. Do you know that you're going to find the answer? Negative 5 over 11 in brackets 400 plus 12 over 11 in brackets 185, and you shall get 20. You shall get 20 after that. Then the next thing shall be the next row and the same column. 3 over 11 by 400 plus negative 5 over 11 by 185, and you shall get 25. That too. So the other thing that you're supposed to tell yourself is that when we take the identity matrix and we multiply by any matrix, the matrix remains unchanged. So multiplying a matrix by the identity matrix is like multiplying a matrix by 1. It remains the way it is. So xy on the left remains xy. And on the right, we are already having 20, 25. So now you equate corresponding elements. X equals to 20 Kenya shillings now. Y equals to 25 Kenya shillings. So the cost of an orange is 20. That of a mango, 25. Yeah, 20, 25. Now look at the last part in this question. What are we being told by this particular, what are we being told by the examiner here? Use the matrix method to calculate the total amount spent on the purchase of 26 oranges and 64 mangoes. So you write like this, 2 matrices, 26 oranges, 64 mangoes. That is a row matrix. Then we multiply by a column matrix. The price of each item, 20 and 25 respectively. So when you perform this multiplication, we are multiplying the row by the matrix. So 26 multiplies 20 and 64 multiplies 25. So what are we getting at this point? When you carry out that multiplication, you'll get 2120. So that's the cost of the purchase indicated. Very good work. So it's my hope that you have followed through. It's my hope that you shall understand what we are doing in this platform. So that is it. I said we shall do all the questions. You are advised to choose, but in this forum, we shall explore all the questions so that during your own time now, you can check which one is easier for you. In case you had been told, in case you were taking part in this particular examination, then you've been told to choose your best 5 questions. What would have been the best 5 according to yourself and according to what we shall do here? So just explore the questions very well. Don't write yourself off. Don't think that mathematics is difficult. Please get encouraged and pursue this subject. Mathematics is a core subject. Very simple. Once you start understanding mathematics, there is nothing that can take you back. Once you begin understanding mathematics, there is something that can take you back. There is nothing that can take you back. So all the best as you continue learning. Let's look at a very interesting question here now. This is from Transformations Book 2, yeah, which is paper 1 work. A triangle ABC with vertices A 17, B 47, C 59 is mapped onto A prime, which is A prime is 15, B prime 75, and C prime 99 by an enlargement. That one has been specified by an enlargement. By calculation, determine the center and scale factor of the enlargement. I want you to know very well that if you had not been told by calculation, then it means there are other methods like graphically. You can use a graph to establish the center and the scale factor for the enlargement. So what do we do here now? We use calculations. And for you to use calculation, let me just tell you the truth. You are supposed to reason in this case. Most of for a question like this, you must be a thinker. You must be a thinker. You must be thinking well. You must be reasoning well. So this is what we are going to do. Do we understand what an enlargement is? And if we understand an enlargement, how do we proceed to ensure that we have enlarged? How do we enlarge? So for you to enlarge, you are supposed to connect a point to a certain center, then from the center now to the image side. And you do the same for the other point. And that continues until you enlarge all the coordinates. So if I have to do a sketch here, then I would say this. There is a line here that I would say, if this is coordinate A, which is 17, then I'm supposed to connect A to a known center, C. Then, I may not call it C because we have a coordinate C involved in this working. So we can have the center being, the center of the enlargement being X. Then now I take it again to A prime, which is coordinate 15. So I'm moving from 17 to 15. Okay. Can I be more realistic? Okay, let's have it that way. Then there is another coordinate here that we are calling B. Then we connect it to the same center. Connect B, which is 4, 7, to the same center, X, and we take B to B prime now, which is 7, 5. That way. Yeah, 7, 5. 7, 5 like that. So now there is an interpretation I want you to get. I will use equations of straight lines together with something called intersection of points. So the line AA prime will have an equation, and the line BB prime shall have an equation. The two equations are supposed to meet at their known center, so we can find their point of intersection. So for line A prime, what shall be the gradient? We need to take 5 minus 7 divided by 1 minus 1. So I'm getting -2 over 0. The gradient is at infinity, which means this is an horizontal line. This is a vertical line, sorry. Yeah, a vertical line. Actually, AA prime is a vertical line. AA prime is a vertical line. So to be more realistic now, AA prime is a vertical line. Yeah, it's a vertical line. Let's not, because it's just a sketch, but you should know that it's a vertical line. So how can we get the equation? Instead of writing the gradient as infinity, leave it as -2 over 0. So -2 over 0 equals to change in y minus 7 out of x minus 1. I'm using coordinate A at the xy. So when we multiply y, it disappears. It's 0 together with the -7. This will be -2x positive 2. So 2x can become positive on the left, equals to 2. For you to remain with x equals to 1. So here, the equation of the line, the first line, AA prime is coordinate. AA prime is equation x equals to 1. After that equation now, can we talk about the equation for BB? BB prime. We begin by the gradient for BB prime. So we can use 5 minus 7 out of, I've taken 5 minus 7, so I should take 7 minus 4. This is equal to -3 out of, no, -2, sorry, not -3. -2 out of 3. So -2/3. Now I'll use 2/3 equals to change in y minus 7 out of change in x minus 4 using coordinate B. And xy cross multiplication will give us 3y minus 21 equals to -2x positive 8. So this is 3y equals to -2x plus, this is 29. That way. So we have the equation for line B prime. So the two lines are meeting. That means we can equate. So where there is x, we put -1 because this is the first equation for the first line. This is the second equation. So to solve simultaneously, we just need to say 3y equals to -2. X is 1 plus 29. So what shall be y? 3y equals to -27, positive 27, meaning that the value of y is equal to 9. If the value of y is 9, Then we have gotten xy, meaning that the center for this enlargement is coordinate 1, 9. That is the center for the enlargement. It's also good for me to mention that we could still have used C prime, because C should be connected to the center, then we move to C prime. So we can also use the third line, but now 2 lines are enough. That's why I used the first and the second. But in case we use the third one, it would still be the same. Now, something else that we're supposed to understand is that with the center now, things are now simpler. We should again know that there is something called the scale factor that again relates A and A prime through the center, and also B and B prime through the center. So let's refer to the coordinate A. Now, the distance from A to the center can be given us. From A to the center, we get the vector from A to the center. The distance A to the center, you know, the center we had let to be X. So I think it's good we keep identifying it as center X. The center X, yeah. So from A to X, which is this vector, from A to X. So we need 1, 9, and coordinate of A, 1, 7. This is going to be take up using the right coordinate. Okay, or we could have gone for B because we are getting a 0 and 0 is not reliable for confirming. Let's just use the second coordinate B. Let me use from B to the center. So I will require 1, 9, and coordinate of B is 4, 7. So I'm having -3, 2 that way. What about from the center to B prime? I will take B prime. Do you know B prime is 7, 5 from the center, 1, 9. So I'm finding this is a 6 and this is a -4 that way. So now we are supposed to tell ourselves that the distance from B to the center should be multiplied by a certain constant to give us the distance from the center to the image. And from this, can we confirm the coordinates of, okay, the value of K? When you use the X component, -3K equals to 6. So the value of K is -2. From the Y components, 2K equals to -4. So K equals to -2 again. So you can use the X component or the Y component to confirm the value of K that way. So that is the coordinate. The coordinate is here, and now the scale factor is a -2. So -2 is the one multiplying in this. We can also prove using C. Ask ourselves, from C to the center, what is the vector? The center is 1, 9, and C is 5, 9. We can see the 0 is coming again, but we can just continue with it. This is -4, 0. What about from the center to the image? So the image of C is 9, 9, and the center is 1, 9. So you see I'm getting 8, 0. So what is the constant? We should say that K multiplies -4, 0 to give us 8, 0. So what is the value of this K? It is confirmed to be -2. So we can confirm with all the coordinates together with their image that the enlargement scale factor is a -2. So these are just continuations. We are already at the point. So we have the center, 1, 9. The center 1, 9. Enlargement scale factor -2. Let's plot what we have been told to plot now. In part B, draw the triangle ABC and also A prime, B prime, C prime on the grid provided below. 1, 7, 4, 7. 1, 7, the coordinate is here. Then 4, 7, and 5, 9. 4, 7, and 5, 9. 5, 9 should be up here. 5, 9. And 5, 9. Yeah, that way. So now we can get the diagram. It's good for you to label the coordinates. It's very advisable to have your coordinates labeled. Even before connecting, actually, I usually advise my learners to ensure that this is coordinate A, B, and C. Even before you connect them, immediately after you plot a coordinate, identify that coordinate. Just identify it immediately after plotting. Yeah, immediately after plotting. We can proceed now to the second thing. 1, 5. 1, 5. That way. Then else we also having 7, 5. 7, 5. Then what else are we having? What else are we having? 9, 9. Coordinate 9, 9, which is here. So this is A prime, B prime, and C prime. So let's connect all that for us to get plotted. Are you guys commenting? Are you following? Tag your math teacher kindly. Yeah, you see? You see now? You see? So we have the triangle and its image. That is what the examiner wanted. Nothing more, but like luxuriously. Luxuries now. You can just the good one. Let's check the enlargement. You connect A to A prime and you draw the line. A to A prime. Then B to B prime. Then C to C prime. No, C and C prime are along the same line. Wow, you see? All of them are intersecting at point what? Look, all of them are coming to the center, 1, 9. All of them are coming to the center, which is 1, 9. That way. They are all coming to the center, 1, 9. You discover from A, actually we are having 2 units here. We are moving 2 units. 2 units. That way. So I think that is now properly drawn. Though the scale factor is proving to be positive, I will check. I'll later check what the issue is, but the center is already confirming to be the one. Let's proceed. first. In part C, on the same grid, we are supposed to draw A prime, A, B, C double primes, the images of the first image after reflection on the line y equals to y minus x equals to 0. That means the y can be equal to x. So line y equals to x can be drawn first. What is line y equals to x? And is this domain going to accommodate 1, 1, 2, 2, 3, 3, 4, 4, 5, 5? That is what we call y equals 2. So let me draw the line first. Call it the mirror line for the transformation of the reflection. So let's draw it. So this is the mirror line, y equals to x. With the mirror line now, we're supposed to reflect. And how do we reflect? We reflect by joining every coordinate to the mirror line and moving an equal distance to the opposite side. Therefore, join A perpendicularly, for that matter. We join A to the mirror line. Then we move an equal distance to the opposite side. So when you move to the opposite side, this is where you shall find yourself. So A double prime like that. Then for B, to the mirror line, we connect B to the mirror line and we move the opposite direction and equal distance. So B double prime shall be there. But something funny about C, it is already lying on the mirror line, so it shall not move to any, it shall just remain where it is. So we can now draw that. So from A, B, from A to B, let me call it A to B, and from B to C, then from C to A again. That's how the triangles are mixing up. From there, we check now Roman 2. Roman 2 is talking about the triple prime such that it can be mapped onto. It can be mapped onto. I want us to read this carefully. A very serious instruction here. We are being told that A triple prime should be such that it can be mapped onto the double prime by a negative quarter turn. So if we can map it by a negative quarter turn to become A double prime, then it means from A double prime to A triple prime, we need a positive quarter turn. From A double prime to A triple prime, we need a positive 90 turn. Positive 90 turn, because quarter is 90. Positive 90, because A triple prime should be such that it can come back, it can be reversed to A double prime by a negative quarter turn. So we need our positive. Positive means turning in the anti-clockwise direction. If it was negative, we would have gone to clockwise. But now that it is the positive, we go anti-clockwise. So the center is origin. So we're supposed to take them to the origin if it is A, we connect A to the origin. Let me use even yellow to the center. Then from the center now, 90 should be turned in the anti-clockwise direction. Anti-clockwise direction. So now we're supposed to draw a line here. Then we measure an equidistance this way. We measure an equidistance along this 90 now. The 90 we've measured. We measure an equidistance, and this becomes now our A triple prime. Then we do the same for B. We do the same for C. So B, I bring B to the center, which is the origin, 0, 0. B to the center. Then now from the center, I'm supposed to measure 90 in the anti-clockwise direction through that line. I measure 90. Trying to be very accurate. That I again move an equal distance. I move an equal distance. When I move an equal distance, I shall find myself at that point. Yeah, so this becomes B triple prime that way. Then finally, I bring C. You know, C is already at the center. So I'm supposed to measure 90. Then I move in that direction. So I measure 90. Then I move along that line. Move along that line for an equal distance to the other side. Well, equal distance shall take me to this point. So I'll be having my C triple prime at that point. Now this can be connected to give us the triangle with the triple point, then to A, then back to C. Look at that work. Look at that work. So I'm having the rotated triangle now. The rotated triangle. You can see how the work is decent. So that's what you're supposed to do, guys. That is what you are supposed to do. Now state a pair of triangles which are oppositely congruent. In this one, you are not even supposed to go to the diagram and research a lot of things. You are supposed to tell yourself this, that congruent means equal angles and equal sizes. But what do we mean by opposite congruent? Where rotation has been involved, then that particular image and the object are oppositely congruent. Where rotation has been involved. Where rotation has been involved. So where have we involved rotation? A prime, B prime, C prime. And what did we get? Triple prime. This one, they are directly, okay, they are obviously going to be oppositely congruent. Reason being, it is a rotation that got involved. It is a rotation that got involved. And what does it mean? That we cannot exactly lift one and fit into the other. So there is no way we can pick this second triangle and we fit it exactly. And we fit it exactly into the third. There is no way. there is no way. But where I'm supposed to actually apologize for that, and I play here. I say this rotation and what we call translation. They will give us congruent triangles, and they are going to be directly congruent. But when a reflection is involved, we get opposite congruent. Opposite congruence. Sorry for that. So we are going to check for opposite congruence. We shall examine where reflection was involved. So it is only reflection that gives us opposite congruence. If we were looking for direct, then we consider translation, but we don't have translation here. So we would have gone for rotation. So the answer was written here is for direct congruence. So for opposite congruence, we consider reflection. Where was reflection applied? From A prime, B prime, to give us A double. These ones are oppositely congruent. Because after rotation, you cannot lift the image and you place it back to the object. Even after tilting, even after rotating through a particular angle, they shall not fit. But with a rotation, you can twist the image back to the object where it was. You can twist the object into the image. You can slide an object into the image with translation, or the image back to the object with a translation. So that is what we call direct congruence. So this is opposite congruence. So we consider where reflection was involved. I thought it's good I clarify that. Number 22, guys. This is a question for measurement. I want to mention something about measurement. It is an area which gives learners and students very good marks. Those learners who take their time to master formulae, to understand figures, to understand shapes, to understand solids and common figures, they really find it very good and easy for them. So looking at number 22, we are supposed to apply some formula, and we should be knowing the formula. So we can't approach measurement until we know formula. So as we work out these questions, I have been advising boys and girls to ensure that they are having their calculators, so that once we compute, they can also confirm, is the figure that I'm placing here the same figure that they are getting in their own calculator? Because there are ordinary mistakes that can be made as we type in the calculators. So let's consider that, please. The diagram below shows a solid made of brass. It has a hemispherical part, you can see it, of radius 42, and a conical, we have a conical frustum. So this frustum was cut from a cone, in other words, of height 56. The top and bottom radii of the conical frustum is 72 and 24 respectively. Use pi as 22 out of 7. Part A, calculate Roman 1, the volume of the hemispherical part. What is the volume of an hemisphere? Volume of a sphere is given by 4 over 3 pi r cubed. That means for an hemisphere, which is half a sphere, is 2/3 pi r cubed. So 2/3 pi. The radius of the hemispherical part, 42. This one should be cubed. So from this, I'm getting 155 232 cube centimeters. So that is what you're supposed to come up with. The height of the original cone from which the frustum was cut, or from which the frustum was obtained from. So this is obtained from, let me just show you what it means. There is an original cone from which this frustum was cut. That particular cone was having a height. This particular cone was having height. So let me show you. You can even extend it this way. That way. So there is the extra height here, which was cut off, that we may get the frustum that we can see. So now we are supposed to tell ourselves that we apply similarities and enlargements. We say from the original cone, there was a height. There was a height of 56 plus the x which was cut. Now the ratio of this original height over the small height which was cut should give us the same as when we take radius of the original divided by radius of the smaller which was cut. So the ratios are supposed to be the same because they are both linear measurements. So when you cross multiply, you get 72x equals to 56 by 24, 1344 plus 24x. Now you can group terms together so that x becomes 48x equals to 1344, and the value of x shall be 28 centimeters. So the smaller cone that was cut off was having a height of 28. What about the original height? Original height then was 56 plus 28, which was cut off, and this is giving us 84 centimeters. 84 centimeters. Now look at Roman 3, the volume of the material used to make the solid. This particular solid, we shall need the frustum first, then we subtract, you know, the hemispherical part is like some material was scooped out for us to have the hemispherical part being obtained. So to get the hemispherical part, there is a volume equivalent to that capacity which was removed. So we start by frustum first. For the frustum, we will need volume of original cone. Original cone, you know, volume of a cone is a third times pi times r. I'm talking about the original. So the original r is 72 squared multiplied by height. Then minus the smaller cone which was cut off, a third pi r, which is 24 squared times the height which was cut off, 28, that way. So the original cone is having a volume of 456,192 minus the smaller cone which was cut off, it was having 155,232. Not really. 16,896. So that this for the frustum now, we get 439 296 cubic centimeters. So for us to get now the solid, we need to take the frustum minus the hemispherical part of the hemisphere. So 439 296 We subtract the hemispherical part, which is 155, 232. According to what we did, we started by getting volume of the hemispherical part. So when we subtract the hemispherical part from that, we shall be getting 284, 064 cubic centimeters. So that's how we get the volume of this particular solid. You are supposed to understand what is happening. Understand how is this shape formed? We have a frustum and an hemispherical part has been scooped. That volume has been excavated. It has been scrapped out. So we need a frustum, which is the original cone minus smaller cone. That is the frustum. Then from the frustum, now we subtract the hemispherical space. We subtract the hemispherical space that way. Look at part B. Given that the density of brass is 8.4 grams per cubic centimeter, calculate the exact mass of the solid in kilograms. So we've been told not to round off. That is the meaning of exact. That is the meaning of exact. So I should work around with the formula that says mass is given by volume multiplied by density. Volume times density. This will give us 2,386, 137.6, and these are grams. So the same mass should be converted now to kilograms by taking 2,386, 137.6 divided by 1,000. So this shall be mass is 2,386.1376 kilograms. Yeah, that way. So now we are now having the mass in kilograms. And actually the question from measurement has already been done. It is now done. 10 complete marks. Without a lot of reasoning, just knowing a few formula. That mass is given by volume times density. Knowing a few things like from a frustum, we need original cone minus the smaller cone, which was cut off. And how do we get volume of a cone? A third pi r squared h. Very simple. Let's look at number 23. We are almost winding up. Remember, as I promised, we are going to do the 8 questions. So we shall do all of them. But now as a student, when given in an exam, it is good for you to, according to yourself, there are people with strengths in construction, people with strengths in graphical work. Just weigh yourself as a student and know where does your strength lie, because you can't do all the questions. You must choose your best 5. If you're very good in statistics, please don't escape statistics. They're very good questions. So let's look at number 23 now on statistics. Remember, I've been saying, and I will say again, that statistics will never fail to be in a standard exam, because daily we interact with statistics, so learners should be exposed to statistics time and again. So please know that statistics will always be evaluated, either statistics 1 or statistics 2 or both. In your KCSE, expect statistics. The table below shows the marks scored by students in a mathematics test. Have the marks already displayed here, right? Then what are we told to do? Starting with the lowest mark and using equal class intervals of 10, make a frequency distribution table. Make a frequency distribution table. So let's have the classes first. So we shall have the classes. Have the classes here. Then after the classes, I shall have a tally column, which might not have some marks, but it shall guide me. Then now from there, I can talk about the frequency itself after. So I'm having the class or the marks. Then from this, I'm having a tally column there. Then I will be able to establish now the frequency at that point. So now let me look for more instructions whereby we to start with the lowest mark. What is the lowest learner having here? Is it 20? Let's check whether there is a below 20. So these are 35, 59, blah, 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 20. I'm looking for 20. That's like 20 now becomes the least mark. So if I start with 20, I want you to know that I should go up to 29 because the lower boundary here is 19.5. The upper boundary is 29.5. So the class width becomes 10. So I establish classes now on that basis. That when I start from 30, I should go to 39. That is a class interval of 10. When I start from 40, I should go up to 49. That is an interval of 10 because the lower boundary 39.5, upper boundary 49.5. From 50 to 59, and we're also going to consider the highest so that we may not have a class where there will be nobody scoring those marks. So I can see 80, can see 81. Do we have 90s in this class? These guys were not serious in mathematics. I don't know why there are no 90s. Or maybe the paper was out of 90. That is why people are scoring 81 as their highest. Or there is an higher score than 81. Any score starting with 9? No, I can't see such. So we go to 60 now. Then 70. Then 80 to 89. Okay, 60 to 69. 70 to 79. 80 to 81. So now we are supposed now to place each marks to its own class. We are not supposed to waste any time here. I want you to observe keenly how we shall move with the speed in coming up with a frequency distribution table. So 35, the class is here. 59, the class is here. You place a mark there. 56, you add a mark there. 41, here. 64, here. 73, at this point. 49, here. 46, the same class. 80, the last class here. 56, here. 70, here. 20, the first class. 69, here. 86, it should be to 89, sorry. 86 should be there. 36, this point. 68, here. 64, same class. 53, here. 57, now that they are already 4, this one should tie them that way. 47, here. 62, they are already 4, so we tie like that. 73, here. 54, here. 61, here. 58, this class. 81, this class. 49, They are already 4, so we tie them like that. 65 here, 37, this point, 56, this is the class. Then there is a 75 for this class, 67 for this class, 46, this is the class, 59, this is the class, 33, this is the class, 57. So 57, they are already 4 here. We wrap like that. 48 here, 63, this point, 26, 26 should be in this class. There is 72, whereby 72 should lie here. We wrap that. 51 here, and 28 at this first class. So now we are having now the tallied students. Let's now compile frequencies. The first ones are 3, 4. This is 5 plus 2, 7. This is 10 plus 1, 11. This is 5 plus 4, 9. This is 5 of them. This is only 3. Yeah, that's only 3. So if we try to, let me show you what we shall do here so that we may save on time. We can check the total frequencies. This is frequency by coming up with cumulative frequencies here, because I can see the next question will be calculating what you call median. Calculating median. So check here. We start with 3 plus 4, 7 plus 7, 14 plus 11, 25 plus 9. This shall be 34. When we take 34 and we add 5, we shall get 39. Then when we get that 9 plus 3, we shall get 42. So we are having 42 students. This was a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 by 6 is 42. So the total of them were 42. It means we have placed every student in their own class. So we have our frequency distribution table. We have our frequency distribution table that way. Part B. Look at part B. Calculate the median. How do we calculate median? Median, M, is given by lower class boundary plus total frequency over 2 minus cumulative frequency just before the median class. Divide by F. Then everything here should be multiplied by the class width. So what is lower boundary? This is the lower boundary of the median class. And how do we identify the median class? I want us to identify the median class first. So we take total frequency over 2. You know, when we take 42 over 2, we are getting 21. So now we take this 21 and we examine it according to the classes that we have, following the cumulative frequencies. Where is 21? This is 3, this is 7, this is 14, 25. So that means the 25th student is in the class that has a cumulative frequency of 25. So this is now the median class, the class that accommodates the 21st student. That is our median class. So now that we have our median class, then we start by its lower class boundary. The lower class boundary shall be 49.5. Then plus we take total frequency over 2, then minus the cumulative frequency just before this class. Just before this class, it's a 14. Out of frequency of this particular class now, which is 11. Then class width is 10. We have used class intervals of 10 in this particular data. I'm supposed to take 21, I subtract 14. Then after getting 7, I multiply by 10. Then after getting 70, I divide it by 11. So I'm going to have 6.3636 that way. So when I add this to 49.5, I'm getting 55.8636 to 4 significant figures. Not 4 significant figures, but 4 decimal places. My median has already been established. So this is the median. This one is the median. Look at part C. We are told that on the grid provided, draw a frequency polygon to represent the data above. I talked about statistical graphs, which are commonly evaluated. One of them is the frequency polygon. The other one is the histogram. And actually, in most cases, an histogram and a frequency polygon will be plotted together. Then we also have what we call the ogive cumulative frequency curve, but that one is in paper 2. So in this case, we're plotting frequency polygon. To come up with frequency polygon, we plot what we call frequency against midpoints. Each frequency against the respective midpoints of that class. Actually, in most cases, our frequency polygon shall be mounted on what we call a histogram. Shall be mounted on a histogram. So if it happens so, then it becomes even easier. It becomes easier to maneuver. It becomes easier to work it out. So this is what I would like us to do. I want us to assume that we've even been told to work out a histogram. And how do we get a histogram? You know what this is for? Frequency polygon. What about a histogram whereby we plot frequency against the boundaries? Frequency against the boundaries. So that is now what I want us to apply. And for your information, we usually ensure that according to the data provided, we assume a class just before this one. So we shall begin with 10 to 19, class 10 to 19, which is not having any frequency. Class 10 to 19. Let me now start with the axis. On the vertical axis, we shall have frequency. Then on the horizontal axis, we shall have max. The max will be displayed here. Max will be displayed there. So now, which class do we start with? We can actually break the axis and we start with, I'm assuming a class just before the least one here, which is class 10 to 19. So the least boundary here is 9.5. So that from 9.5 we shall go to 19.5, then 29.5, then 39.5, then 49.5, then 59.5, 69.5, 79.5, 89.5, and we can also have 99.5. Yeah, so I hope. Okay, the scale has accommodated, though it might be proving that we can use intervals of 10, intervals of two big squares. Then for the frequencies, the highest frequency that we're going to plot is 11, and the least is a 3. So if we have 11, then we can start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that. So now for the histogram, we are talking about boundaries and frequencies. So 3 for the first class. So the first one shall be blank, but the second one shall have a height of 3. A height of 3. Let me use this ink now. Don't know whether black shall be better. The height is 3. Remember, for histograms, the bars are supposed to be in contact. The next class shall be having a height of 4. A height of 4. The bars are supposed to be in contact because the upper boundary of 1 becomes the lower boundary of the successor. Then the next one is it a 7? Yeah, then 11. So a 7, then 11, I want to secure your marks, guys. That's why I'm starting with a histogram. In another case, you'll be told to draw a histogram and to ensure that you have a frequency polygon on the same axis. So after 11, we have 9, then 5 and 3. 9, then 5 and 3. So now we can have them drawn very fast. Now we have what we are calling the histogram. These bars are what we call the histogram. But now, what was our intention? Coming up with a frequency polygon. Therefore, for every bar, the middle coordinate at the top shall directly imply the midpoint. Therefore, because the top is also showing the frequency, then it shall automatically be frequency against midpoint. So we can now establish that coordinate in this manner. The coordinate can be established this one at the mid. That is now frequency against midpoint. Frequency against midpoint, that way. Those are the midpoints. Check the coordinate at the midpoint. So my coordinates for the midpoints have been established. So now, let me use now my blue ink or the green to connect each top to the successive top. So this first coordinate, using a very straight line and not anything else, then the next I link up, then the next I link up, then after that now we can continue linking like that. Then we also connect to the other mid. Then after you've connected all the mids like that, you are supposed to know that the frequency polygon is not supposed to be suspended in the equation plane. It should be anchored on the axis. So now the mid of this class, which I told you to begin with, is what shall anchor. That is where it is anchored like that. Then after the last class, the mid of another class beyond the ones that we have, we also anchor it there. Please follow up to such extent. So now the green diagram now is my frequency polygon. This one is the frequency polygon now. The frequency polygon. That is how we're supposed to come up with it. That is how we are supposed to establish a frequency polygon. A frequency polygon. I've told you in other cases, you will be supposed to draw it together with a histogram. And in such cases, that is what you're supposed to do. At number 24 now, our last question. What are we told here? The question says that a bus left Nairobi to Wajir, a distance of 500 kilometers and back to Nairobi. Its average speed for the return journey is 20 kilometers per hour faster and takes 1 hour, 15 minutes less. If the average speed of the bus from Nairobi to Wajir is X kilometers per hour, write an expression for part 1, the time taken by the bus from Nairobi to Wajir. How do we get time taken? Time is usually given by distance out of speed. So in the first case, time shall be the distance out of the speed. The time is in hours. Then another expression in Roman 2 should be that an expression for the time taken by the bus from Wajir to Nairobi. So Wajir to Nairobi should be the same distance, but now at a speed which is 20 kilometers per hour higher. So we are taking lesser time. By what? By 1 hour, 15 minutes. So calculate the speed of the bus from Nairobi to Wajir. We're supposed to know that this time difference of 1 hour and a quarter, because 15 minutes a quarter, can be written as 5/4. It can be written as 5/4. So at that stage now, at that particular stage, we can talk about the time difference. The time in the first journey, which is longer, over X, minus the time in the return journey, which is a smaller time, should give us a time difference of 5/4. And with this now, guys, we can work out what we want. So now the LCM shall be X for the denominators times 4 that way. So LCM divided by the first denominator, it is X that shall cancel. So we shall have 500 multiplying what? 4x plus 80. I hope we are together in that, because it is x that cancels from the LCM. The other part of the LCM should multiply the numerator, 500. Then minus 500 again. What does 500 multiply now in this case? LCM divided by the denominator, x plus 20 cancels, and we remain with 4x. I hope that is clear now. This is equal to, let me extend this line, 5. And what does 5 multiply? LCM divided by 4. 4 cancels, and we shall remain with x squared plus 20x. Yeah, x squared plus 20x. That way. At this point, guys, allow me now open brackets, and remember we are done with the LCM because we have already multiplied everything by the LCM. So now we open brackets, and this will give us 2000x plus 40,000 minus 2000x. This is equal to 5x squared plus 100x. That's right here. That's okay. So now if we group terms together, we shall discover 200x minus 2000x again. That one cancels. So now we can group and start with 5x squared plus 100x. Then you can minus now the 40,000. Then this is equal to 0. If that is so, this equation now can be solved after, of course, simplifying, because you can see that it has a common factor here. When we factor out 5, we shall remain with x squared plus 20x, then minus 8,000, and this is equal to 0. So now at this point, we can find the value of x. We can use the quadratic formula, just to remind you, quadratic formula, or because of the form 2's in the house, let's use factorization. Product a times c, negative 8,000, and a sum which is equivalent to the value at b, which is 20. Two factors, when multiplied, they give us negative 8,000, and when added, positive 20. This is supposed to be 100 and negative 80. Their product is negative 8,000, and their sum is positive 20. So now we can write x squared plus 100x minus 80x, then minus 8,000 equals to 0. You see, instead of 20x, I have replaced it with the two factors that can be added to give b. 100 and negative 80 are the same as 20. So from the first two, we can factor out x. So that will remain with x plus 100. Then in the others, when we factor out 80, we also remain with x plus 100 equals to 0. From the brackets, we are having x plus 100, and outside the brackets, x minus 80. This equals a 0. That one equals a 0. If that equals a 0, then it means we can now start winding up and talk about x plus 100 being a 0, or x minus 80 being a 0. So x is negative 100, or x is positive 80. What are we told to find? The speed from Nairobi to Wajir. From Nairobi to Wajir, that is the speed which we had let to be x. So this speed is supposed to be 80 kilometers per hour. The reason being, speed cannot be negative as long as this vehicle was moving. So we have it as 80. Now we ignore the negative and we work with 80. But now we're supposed to know that the return journey, the bus used 100 because it shall be moving 20 kilometers faster. 20 kilometers faster. Let's check number 24, part C. A car left Nairobi to Wajir the same day. At the same time, the bus was starting its return journey and met the returning bus after traveling for 187.5 kilometers. Determine the average speed of the car. So, if the car will cover 187 to meet the bus which is returning, what distance will the bus have covered? So, distance covered by bus. The bus has covered a distance which is equal to 500 kilometers minus 187.5. So the bus from Wajir, the bus will have covered 312.5 kilometers. So if the bus has covered 312.5 kilometers from Wajir to the meeting point, then what time has the bus taken? Time is given by distance out of speed. It is moving at 100 in the return journey. So 3 hours, so 3.125 hours. This is the time it shall take. That means because they began at the same time, when the bus was starting the return journey at a speed of 100, the car also started the journey from Nairobi towards Wajir. Now, you are supposed to know something here. You're supposed to know something. That the time which the bus has taken to meet with the car is also the same time the car has taken to meet the bus. But now, as the bus covered 312.5, the car has covered 187.5. So within the same time frame, the car was also traveling. So speed of the car shall be given as the distance it covered, the distance the car covered, 187.5, out of the time it's going to cover this, which is 3 hours point 125. Use your calculator wisely and confirm 60 kilometers per hour. That is the speed of the car. It means the car is slower than the bus in this particular case. So that is it. Thank you so much for following. Remember to subscribe. Remember to share so that you may invite a friend to these lessons. Welcome to Shifting Grades. Remember our platforms. Come with a friend next time. All the best to the candidates, all the best to the students in the lower forms in your journey in education.